Hello students, this is Mr. Ezra. In the last video we talked about how to solve quadratics using the square root method. And the square root method is a great method when you have an x squared as your only variable or a binomial squared and the variable is in that binomial and that's it. But that method doesn't work every time you're dealing with quadratics. So today we're going to look at another case. These are going to be solved by something that we call factoring. And you've probably factored in the last year or two in school. We're going to start out with some easy ones where the first leading coefficient, which we're going to call a, is equal to 1. So these are the steps in order, and you do have some guided notes on this if you want to use those, or you can take the notes on notebook paper if you'd like. But these are the steps that we're going to use to solve by factoring when a is equal to 1. So the first thing that you have to do is to put your quadratic in standard form. The quadratic equation must be in standard form. That means the x squared part is first, the x part is second, what we call the constant, the part that doesn't have a variable, is third, and it's always equal to 0. So if we get to problems where it's not equal to 0, you're going to have to add and subtract stuff to one side of the equal sign so that this works out. Well, in these questions that we're looking at today, a is always going to be equal to 1. So we're really going to be starting with x squared plus something x plus c something equals to 0. After we put these in descending order from the highest power of 2 to the lowest power of not having an x, we're going to list the factors of c. So remember, factors are basically the things that multiply to give you a number. So if I said, what are the factors of 10? Well, the factors of 10 are just 1 times 10 and 2 times 5. But we also have to think about -1 times -10 and -2 times -5. Those would also be factors because they would multiply to give us 10. So we're going to be looking at both positive and negatives, and the quadratic will tell us which of these we need to focus in on. Let's clear that out. So once we list out the factors of the c, the constant term, we'll determine which factors of c would add together to give us b. So you can think of this as what factors of the end number add together to give you that middle number. Okay, we will create 2 binomials using the variable that we started with, and it'll be at the beginning of each binomial is equal to 0. And then the factors that worked for us, that added to give us that middle term b, will go in the spaces that we've left behind. Then we'll set each of those binomials equal to 0 and solve for each one to find out what the value of the variable. So if you remember from the last video, we said that quadratics always have 2 solutions. So when we finish this, we should have 2 solutions. We should have 2 things that the quadratic is equal to, that the variable of the quadratic is equal to. So for the first example, I've kind of already worked it out, and what I'm going to do is go step by step, and I've labeled it based on the steps that we saw on the last slide there. So as we go through step 1, step 2, step 3, I've labeled each of those spots on here. It's the only time I'll do that, but it'll kind of give you an idea of what we're talking about. So we'll start with step 1. The first thing we want to do is to get this in descending order. So this x squared is not first, but it needs to be. So I'll move it using the commutative property to the beginning of the quadratic. 8x would be next, plus 7, always equal to 0 when we do this. Now notice that a is 1, like we said it would be. B comes from the middle term, it's 8, and c is 7. Once we put it in order, we can identify a, b, and c. Now the second step is to find the factors of 7. Well, that's going to be pretty easy for us. Really, there's really only 1 and 7 because it's prime. Or, of course, if we needed to use negatives, it could be -1 and -7. Now, the third step is to say, well, which of those factors together would add to give us the middle term? So our goal for this is the middle term of 8. B, 8. Well, 1 plus 7 is 8. So tuck that away. 1 and 7, those are the ones that we're going to use in just a second. Our fourth step is to put x space in parentheses and another x space in parentheses equals 0. And our fifth step is to plug in the 1 and the 7 that we got, the factors of 7 that added to give us 8. Okay. Now at this point, all of this seems like a lot of work, but I'm going to show you in a minute that it doesn't take as much space to do all this. We're just kind of listing out every step as we go along. Our sixth step is to set each one of these guys equal to 0. This is called the zero product property. Product is a word we use for multiplication. So basically, if you think of it this way, if x plus 1 were equal to 0, 0 times anything would be 0. Or if x plus 7 were set equal to 0, 0 times whatever's in the first parentheses would be equal to 0. So if either of those binomials is equal to 0, we've got a solution. Well, those are easy to solve. You subtract 1 on the left one and you subtract 7 on the right one. So we get two solutions, -1 and -7. What I like to do is just bring them together in one answer. X is equal to -1, comma, -7. We circle that up and say, we got it. That is our solution. So from here on out, I'm not going to list out every step along the way, but we're still going to use those same steps to solve these quadratic equations. So first we check to see is it in standard form. The n squared is first, the n is second, and the constant is third, and it's equal to 0. So that is a check. So now what I'm going to do is I'm just going to go ahead and skip to step 4. I'm going to go ahead and put the n here and the n here. Now this works because n times n is equal to n squared. So we know that we're good with our first terms. In order to find the right side, we have to find factors of c. So remember, a is always 1 with these, b is the middle one, it's -11, and c is the right one, it's 10. They always keep their signs, whether they're positive or negative. So our goal is to find factors of 10 that might add to 11. Well, there actually aren't very many factors of 10. There's 1 and 10 and 2 and 5, right? Well, when we look at 1 and 10, 1 plus 10 is 11. This is the sum over here, right? Didn't work, but it's pretty close. And 2 plus 5 is 7, and 7 didn't work at all. Well, that pretty close is there for a reason, because this middle part is negative. So we know that our signs have to be the same. If we're going to multiply to get a positive number, our signs have to be the same, but they both could be negative. And this is the case where -1 times -10 is positive 10. But when we add them together, we get our goal. Whoops. We get our goal, which is 11. That is the winner chicken dinner. That's the one that adds to give us B, that adds to give us -11. So the -1 and the -10 get plugged in, and we're good to go. So once we identify this, we use the zero product property. We say, well, n minus 1 must be equal to 0, and n minus 10 must be equal to 0, and we solve those to get in +1 and +10. So I like to write those together and say n is equal to 1, comma 10. Okay. Now, really quickly, if you're unsure if you got the right thing, you can always FOIL this, right? N times n is n squared. N times -10 is -10n. -1 times n is -1, and -1n. And -10n plus -1n is -11n. And then -1 times -10 is 10. You can do it off to the side or you can do it in your head. But this should FOIL to go back to the original quadratic that you started with. Another way to check your solution, it's always a good idea when you're solving any equation, is to plug in 1 and 10 to make sure that they work. And I might not say that every time, but it's something that you should do, especially as you're kind of getting used to this process, to make sure that you get the right answer. 1 squared, 1, minus 11 times 1. 1 minus 11 is -10, and -10 plus 10 is 0. So 1 works, and the same thing would work with 10. It would work as well if we plugged it in. So here we've got the variable m. So I do notice that it is in descending order already, so I don't have to change anything. 0 is on the right, that's good. So I'll keep 0 on the right. And now I've got to find factors of 90. So let's come over here, maybe right here, and actually notice that it's negative. So if a is 1, b is also 1, and c is -90. That's what happens when you speak right at the same time. So remember the 0 doesn't matter. It's A, B, C like that, okay? So C is negative 90. We've got to have things that multiply to give us a negative. Now, if we said 1 and 90, well, that doesn't really work because 1 times 90 is positive and we need a negative. So either the 1 would have to be negative or the 90 would have to be negative. So when you have a negative number at the end, you have to have opposite signs when you're factoring. Well, these do not come anywhere close to adding to 1, right? Negative 1 plus 90 is 89, and this would be negative 89, so those don't work. So we kind of want to continue going through things that divide evenly into 90. You can try 2 and 3 and a whole bunch of other things, and eventually you'll get down to negative 9 and positive 10. And negative 9 plus 10 is equal to 1. And that is what we want. Something that multiplies to give us negative 90, but adds to give us 1. So I'm going to use negative 9 here and positive 10. Right? I set each of these equal to 0 using the 0 product property. And then I solve. And these one-step equations are super easy. They're just going to be the opposite sign. Because when I add 9, I get the opposite of negative 9. And when I subtract 10, I get the opposite of positive 10. So negative 10 and positive 9. Now, it really doesn't matter what order you put these in, but I sometimes try to remember to put them in order from least to greatest. But you could put 9 comma negative 10. It would still be just as correct. I'm going to divide that off there. All right, we got question number 4, where we say, is it in descending order, the way that it's supposed to be? Check, 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 yep. Let's go ahead and use our variable here and here. And we got to come off to the side and find factors of negative 56. Let's see, I could probably draw a straighter line than that. All right, well, again, if we tried negative 1 and 56, I know one of them has to be negative. I'm going to be pretty far away from B, which is negative 1. All right, so since B is negative 1, I need something that's closer together than this. So I'm going to keep looking at factors, and maybe I get all the way down to 7 and 8. So I realize that one of them has to be negative and one of them positive. So negative 7 plus 8 is positive 1. Well, positive 1 won't work. I need a negative 1, right? So how could I get that? Well, I just switch the sign to be 7 and negative 8. That is the winner that gives me a sum of negative 1. So plus 7 minus 8. Again, we'll use the 0 product property. X plus 7 equals 0 and x minus 8 equals 0. Subtract 7, add 8, and we've got our two solutions, negative 7 and positive 8. All right. Maybe a good idea for you to try this last one on your own. So if you want to pause the video and try it, that would be a great thing to do, and then come back and check and see if you got it right. I'm going to try to speed through this one. So I know I've got descending order, 0 on the right. So I'm going to start with x, because that is my variable of choice, or the variable that's there. I want things that multiply to give me negative 104. Well, I know negative 1 and 104 are going to be too far apart because my goal is to get a sum of negative 5. And I need something closer together. So I might try 2, I might try 3 and 4, and just keep going down those numbers until I get something that's closer together, like negative 8 and 13. And again, when I add negative 8 plus 13, I get positive 5, not negative 5. So got to make sure that the negative is on the larger of the two numbers. 8 plus negative 13 is negative 5. That is what we're looking for. So these are our two numbers that we're going to use, plus 8 and minus 13. We'll use the 0 product property one more time. X plus 8 equals 0, and x minus 13 equals 0. Subtract 8 and add 13. So our two solutions are negative 8 and positive 13. Again, with all of these, if you're unsure, you want to check your answers, just plug it in and see if it works. Well, I hope that that's enough practice there for you to get comfortable to either remember or learn how to factor and solve a quadratic when a is equal to 1. I will see you in class.